This lesson is about taking different functions, which we will call something like f of x and g of x. Anytime we have a new function, we'll use a different letter, and we'll do things with them like add them, subtract them, multiply them, and divide them. So the way that works, and I think we went over this in class today, but is we could have two functions. Here's f of x, and here's g of x, and I could ask you something like this, which means basically take f and take g and add those two functions. So what you're getting is f of x plus g of x, and then just use algebra, add like terms, and this would be the answer, f plus g of x. I could also at some point give you an x value to plug into that. Like for instance, if I said x was 2, then you would plug in 6 times 2 like this, 6 times 2 plus 2, and give an actual value for that. All right, so the same thing works for subtraction. We're taking f of x minus g of x. We want to be careful here with distributing the negative like we've worked on before with polynomials. 5x minus x will be 4x, and then this negative has to also go to that 2, which is how they're getting negative 2. Okay, so same thing with multiplication. As you can see, we'll distribute and then division. So that part is easy. That's not necessarily what this video is about. This video is about taking those things and finding the domains of the final answers. So let's review what the domain is. The domain is everything on the x-axis, because the domain is x values that work in the function, meaning what does not make it undefined. So when we're working a sum, difference, product, quotient, it consists of the x values that are in the domains of f and g. So in this case, let's say f of x, remember, was 5x. Was there any x value? Because we always start with all real numbers or everything on the x-axis, and we start taking away numbers that would make that function undefined. So I like to look at it as parts. I start with 0. Will 0 make that function undefined? No, because 5 times 0 is just 0, and that's an okay answer. And then I look at it as positive numbers. Are there any positive numbers that will make that illegal or undefined? No. And are there any negative numbers? No. So in that case, we use the answer all real numbers. Now, g of x is also a line. If you think about the graphs of these things, they're just both lines. And so that one also, I can't pick any value of x that will make x plus 2 undefined. That's also all real numbers. So when I look at the answer here, what that sentence says that we just read is that the domains of the sum consists of the x values that are in the domain of f and g. Well, all real numbers is in f and all real numbers is in g. And lucky for us, 6x plus 2 is also a line, which is also going to have a domain of all real numbers. And so that's going to be the same thing for subtraction, because again, these are two lines that are being subtracted that give us another line. There is no value for x that I can choose that's going to make this undefined. All right, so when we start getting exponents, we have to think again about, just start thinking about positives and negatives. Will 0, if I plugged in 0 for any of these x values, would it make it undefined? No, it might make my answer 0, but that's okay, that's a good answer. What about positive numbers? No, positive numbers are going to give me some sort of value. Negative numbers are also going to give me some sort of value. So in this case, everything works again, and I have all real numbers. And by the way, you guys know that that's some sort of parabola, and there's nothing on a parabola that will be undefined. All right, now with division, that's what the second sentence is about. This part goes with the second sentence. The domain of the quotient does not include x values for which g of x is equal to 0, because g of x here is this denominator, and anything, any number divided by 0 is undefined. You can't do that. So what we have to do is figure out what will make this bottom part 0. So we take x plus 2 equals 0, therefore x has to be negative 2. So -2 is the only thing. Everything else for 5x works, all real numbers, remember again. And the only thing that won't work is if x was -2, because it would make that entire function undefined. So the way you would say that is a couple of different ways, and we'll investigate what the book uses. But I like to say all real numbers except x equals -2. So that's one way you can do it. There's lots of different ways. So let's practice something that we have in the book. This is in your workbook under the extra practices in 5.5. I don't have the page number with me right offhand, but basically you're just solving. This tells you to solve f plus g of x. So that means take -1/2 the cube root of x plus 9/2 the cube root of x. And that will be 8/2 times the cube root of x, which is really just 4 times the cube root of x. So now the biggest thing again that I'm looking for is the domain. So the domain of this would be anything that we think could make cube root of x undefined. Well, the cube root of 0 has an answer. The cube root of all positive numbers has an answer. Now think about this. Can we take the cube root of negative numbers? And actually we can, because negative times negative times negative is negative. So in this case, again, it will be all real numbers. So that's kind of the process that you use to decide what the domain might be. And most cases it's going to be all real numbers, but you do have some situations, like for instance, if I had a square root of x, or a fourth root of x, or a sixth root of x, can you have negative numbers? Can you take the square root of a -16? No. So in that case, you would exclude the negatives, but the positives and 0 are still okay. Okay. All right. So going back to our problem, sorry, -1/2 the cube root of x minus 9/2 the cube root of x is, let's see, -10 halves the cube root of x. I'm just adding the two coefficients because I have like terms and I also have like denominators. So they kind of set this question up very nice. -5 times the cube root of x. Again, the domain, there's nothing here that's going to make this undefined, so the domain is still all real numbers. Okay, and this one, I can already see that I have a polynomial, I'm sorry, I have a parabola. I have another parabola. So honestly, when I take an all real numbers and an all real numbers and I combine them, I'm still going to have a domain of all real numbers. So all I'm really trying to do is add these two things. Okay, so that would be -4x squared. -3 and 6 would be +3x, and then plus 8. Okay, and as I can see, I have another parabola, so my domain is all real numbers. Now the rest of these instructions do say to plug in the x values here, but we're going to do that in class tomorrow because we'll finish out the whole lesson in class. Okay, so here's an example of a subtraction problem. So we're going to do subtraction. Make sure to use parentheses here so that you remember to distribute the negative. So this will actually distribute to -6x plus 3x squared. Therefore, I don't need that anymore. -x squared, -6, oh, I'm sorry, -x squared and +3x squared is 2x squared. -6 and -3 is -9x, and then +8. Again, I have a parabola, and I know that there's all real numbers because there's nothing that can make that undefined. The only thing you really want to look for are square roots and any denominators when you consider things that make it undefined.